Hi, sustainers. It looks like you guys were having some trouble with the first stage of your project, and I can see why. There's some really kind of challenging stuff if you're not used to programming. So let's go through one step of the project of this stage of the project. So in particular, I want to focus on step 3 here, and what I want to do is actually do the stuff for the surface albedo and show you how to do it. So let's start by opening the model. If it fails to open and you get a page not found error, try refreshing and see if that works. If that doesn't work, try going to Insight Maker's homepage and then trying to load the model again from compare. Sometimes that process will help it. Okay, so your first task is to understand how the model works, and that's something I'm going to leave to you. You have to figure out what all these things kind of do and how they work together. Most of that is kind of explained through the story, so you should view the story and make sure you understand that. Excuse me, make sure you understand that. But there are other things, there's like the formula for the surface temperature, which is not immediately obvious, but I try to explain it with a comment here, for example. So it's just saying that energy is related to the temperature through the specific heat and the mass of the object. And that's the relationship I use to calculate the temperature of the surface. And likewise, let me show you the equation for the greenhouse effect. So this is just based on the Stefan Boltzmann law, which you might not know because it's kind of a fancier physics thing. But it's basically saying that any warm body will emit radiation, and it says how it emits radiation. You can look it up on Wikipedia and figure out what it's saying. And basically, I've just plugged in that equation here in this stuff. So take a look if you're interested. That's not so essential to understand that in detail, but that general idea of how you write an equation and how you include units, those are things that you should make sure you understand. Okay, the reason we're here is because we want to look at how we can introduce feedback into one of these elements, either into the surface albedo or the greenhouse effect. Your task is to do both, but what I'm going to do here is show you how to do it with the surface albedo. So let's go through the steps here. We've logged into Insight Maker. That was step 1. Step 2, sorry, the rest of step 1 is to clone this model. So let's go up here, clone Insight. Are you sure you want to clone it? Yes. Okay, so we've got a clone now, and I can work with that. So I want to introduce a converter, basically, that will take the surface temperature and turn it into an albedo. So it's a way of saying for any given value of surface temperature, here is the albedo, which might sound familiar from algebra. That's the definition of a function. And so that's what we're talking about with the converter. So I will do this in a few steps here. Let's do the first thing, add a converter. Okay, we have a converter. I'm going to drag it down here, and I need to call it something. Let's say what it does. So it will convert surface temperature to albedo. So let's just call it. That'll make it a little bit clearer why it's there and what it's doing. Now it has to depend on stuff. So the thing that it's taking input from is the surface temperature. So we need a link from surface temperature. Notice how I click links here. And then I grab this arrow here and I drag it to there. You'll notice the converter was highlighted when I did that. So now they're connected to each other. So now I will be able to have I'll show you later what it does. Let me step back and do the next link. What I want is the output from that converter to go into the surface albedo. Now that's not enough because the surface albedo still isn't going to depend on the converter until I tell it how it should depend on that converter. And I just want it to be that value. Right now, if you just use this, it would still the surface albedo would still always be 0.3. I don't want that. I want it to actually be the value of that converter. Okay, now I just need to specify what the values of the converter should be. Okay, so here's how you determine that. You click on the converter and then you can click on the little equal sign. You can also go to the data here and choose the drop down. Either way, we'll give you this window here. And the top part of this window is showing you the value of the function, what the output is as a function of the input, the surface temperature. It knows the input is supposed to be surface temperature because we made that link. So what I want is that the albedo should be really high, something like 0.7 when it's cold, and then it should drop down to something low when it warms up. And the idea there is the albedo is a reflectivity, and so when it's cold, the planet is covered with ice, and it has a high reflectivity. So the input is the temperature in Celsius. So let's say all the way from minus 273, it should be high. And let's say for high, we choose 0.7. And then maybe around like, I don't know, minus 50. You have to decide what a reasonable number is. We're talking about the global average temperature. So maybe at minus 50 for an average temperature, maybe that's when the equator starts to finally just break zero. I don't know if that's reasonable. Maybe it should be a smaller number, but I'll leave it to you to think. Sorry about that. Got a phone call. Okay, where was I? So I was saying that I want the lower temperature to be minus 50, and my argument was that maybe when the global average is minus 50, then the very warmest part of the planet reaches zero and starts to melt. And so then the albedo would start to go down, the reflectivity. So maybe up to that point, it's still 0.7, but it's going to be continually declining. And let's say when we hit like plus 50 degrees Celsius, then we hit a low albedo, let's say 0.1. And the idea there is that by the time the average hits plus 50, then the entire planet has melted. And so the polar ice caps are gone, and we have a low albedo everywhere. And in between that, we have a continuum now, a straight line. Just for to complete this, I'm going to add another point. And so let's say this is like a high temperature. So let's say 200 degrees Celsius. And I want the albedo to stay low as long as the temperature is above 50 degrees. So that's a way we can have the albedo start at a high value when the temperature is low, and then start declining as the temperature increases until it reaches a low value and just stays there for any higher temperature. So if I apply that, then I think I've got all the ingredients I need. So I've got a link from the surface temperature to the converter, from the converter to the surface albedo. I've set the shape I want in my converter, and I've set my surface albedo to be the value of the converter itself. And let's say we turn on the greenhouse effect. We don't need to set the surface albedo now because it's being handled by the converter, so we don't want to set it. Now if we simulate it, what we should see is that everything will go smoothly and steadily until the surface temperature is going to hit about minus 50 degrees, and then we might see like a kink, because that's when the surface albedo starts to change. And so we might see we're going to have a lower albedo, and so probably there's going to be more absorption of heat, so the temperature will start to climb fast. That would be my guess. And if it gets up to plus 50 Celsius, then it'll just stay that level. So the acceleration that we're seeing up to that point won't continue. But I'm not sure if we'll get that high. I think it'll end up below plus 50. So let's look for that kink and see if we see it. Yes, I think I see it. So when the surface temperature is minus 50, then we see this kind of like, it looks like it was kind of settling down here, and then it jumped, kind of went up again. And we see it also in the atmosphere temperature. If we wanted to be sure, we could compare this to our original model. So let me do that. I had set the greenhouse effect to 1, and we had a high surface albedo at first in our new model. So let's set it to that in this model here and see what happens, right? Okay, so I think we can see it pretty clearly here. In this model, the temperature increases. When it hits minus 50, it's slowing down, and it keeps slowing down until it hits a steady state. Whereas when we have the albedo depend on the temperature, then we get this kink, and it climbs again, climbs faster. And we end up with a temperature above almost 50 degrees, actually. Whereas here, the temperature is minus 27.5. So that makes a big difference. Okay, so that's the kind of thing I'm looking for you guys to figure out how to do. I've given you one now. This is a surface albedo, and I've shown you how you can change it for yourself. So your first task will be to actually replicate what I just did. And then the second task will be to do something very similar for the greenhouse. And you'll need to think about what kind of converter you need to put in there. How do you want the greenhouse effect to depend on the surface temperature? Okay, so I hope that helps. And good luck with your projects at this stage. And I'll see you guys all on Thursday. Bye-bye.